the Wolfram Cloud can be used to deploy advanced technologies to relatively simple user interfaces, specifically Excel. So before I dive into any code or anything technical like that, I thought I would start this talk by zooming out a bit and asking the question, what kind of technology are companies using today? And if I were to answer that question myself, it would be quite a wide spectrum, right? I think on one hand, we have companies that have fully embraced digital transformation. These organizations have invested heavily in modern infrastructures. Perhaps they're utilizing advanced analytics platforms, or they've even developed digital twins of key processes, and they've enabled real-time monitoring and optimization and the whole nine yards. But on the other end of the spectrum, I still think there's a lot of industries that can't seem to shake the Excel habits, right? And I think this may be because they haven't invested in anything more advanced. They may be a small company, haven't yet gotten to that, don't see the value in it, things like that. Or what is often the case is that I think people just reach for tools that they are familiar with and what they have sitting right in front of them. And certainly in a lot of cases, that is Excel. And so if we kind of just blindly assume that all companies are leveraging the latest in technology, I think there's a good chance that we miss a really big portion of the companies that aren't. And instead, I think it's important to kind of meet companies where they are. And this is really the kind of the premise behind this talk. So if a company has an infrastructure in place that can easily create and deploy solutions on, of course we should tap into that and use whatever data pipelines and automations and whatever they have set up. But for those companies that may not have that or do still favor Excel, I think the challenge then becomes how can you deliver high-tech solutions to problems, but in a relatively low-tech platform like Excel. And so if you start to think of Excel as a platform for delivering solutions, and just like on any other platform, you could probably come up with some negatives and some positives. And so some negatives of Excel, right? I think most people would agree there's improving, but still relatively poor modeling capabilities, right? So this is physics-based in terms of solving differential equations and doing rather sophisticated math, as well as data-driven. So things like building advanced machine learning models, things like that, is going to be relatively restrictive in something like Excel. It's error-prone, right? It's data entry tends to be manual, or can as easily as data can come into Excel, it's just as easily as it can be kind of messed up. And then just generally like limited flexibility, right? It is a tool. It was designed for spreadsheet use and spreadsheet functionality, but it's been extended to support a whole other things which arguably aren't necessarily in its original design. And it reaches some limited flexibility when it hits some of those. But on the other hand, if you're making a strong case for Excel, right, you would say that it's readily available at most companies, right? I think almost every person working in a company now is going to have kind of an office suite of products, and within that is going to be Excel. And a lot of people have trained on it, used it in the past for various things, so it has a wide audience and a wide user base. Data can be displayed and manipulated pretty easly, right? Without a whole lot of advanced skill sets, a whole lot of build data savvy knowledge. You can still do quite a bit with raw data in Excel, and you can produce user interfaces, graphics, visualizations. All of those are pretty easy to produce right out of the box in Excel. There's even kind of steps or guidelines or things like that kind of walk you through those processes. And in the end, right, I think people have a platform that if they're familiar with it and it has a little bit of that functionality that it can be extendable and flexible, they can do some of that themselves, right? So you're not tied into a platform that's not going to be able to easily adapt to one person's particular wants and needs. So how do we actually bridge this gap, right? So that we can deliver solutions in a more basic platform like Excel, recognizing its strengths and its user base being so large, but still try to ensure that we're using technology where we can write solutions to differential equations or create and deploy machine learning models, and things like that without having to necessarily do that in Excel. And so this is where Wolfram, and in particular, the Wolfram Cloud comes in. I have a high-level workflow here, but essentially what is involved is that we develop whatever calculation logic is required, right? If this is that that differential equation that we're solving, or that modeling of supply chains, or the machine learning model for optimization, whatever it is, right? We're building that here in the developed calculation logic and inside of a notebook like Mathematica. We can then kind of deploy that to the cloud as an API. And I'll walk through this and talk about this, but Wolfram makes this process very, very easy, right? Then we can switch over to Excel and we can build whatever user interface we want in there, right? And yes, we'll be limited because it is Excel, but if the value of what you're kind of doing is more on the calculation and the backend side of things than just getting a platform that you can deliver that to, Excel will work there. And then finally, you kind of hook up whatever you've built in Excel to call out to those APIs for that advanced calculation to be performed. So what are the benefits of this process, right? So the math, right, this calculation logic, in this case, and in many of the cases that I do this, is all being handled by Wolfram, right? And we're all at the Wolfram Technology Conference, and we're hearing about all these impressive things that Wolfram language can do, right? It makes sense to put the sophisticated part of this whole process into a language like Mathematica or Wolfram language, right? Because it can do all of those things. It can do kind of all of the above. The calculation logic then is kind of made separate from the user interaction, right? And this is a standard software design principle that you want your kind of back end separate from your front end. So you put this logic and this calculation into your quote unquote back end, and Excel becomes this front end. And what that also enables you to do is to protect your IP, right? So your IP is in the back end, and your front end really becomes Excel. And it actually doesn't have to be limited to Excel, right? I'll focus on Excel here, but in theory, you can call those APIs from any number of user interfaces that you would like, Excel just being one of those. So for those that are not, haven't really experimented with the Wolfram Cloud, haven't used it much in the past, I'll run through quickly what I think are kind of the top three capabilities, right? So you have Mathematica Online, which is really kind of the online version of the Wolfram desktop product, which has almost all of the functionality that you get with the desktop product. There's a little bit of limiting things just due to things that make sense, like files and whatnot that you might not be easily able to access, or anything that has kind of a security concern associated with it. There's also things called these instant form interfaces, right? Maybe you've interacted with these through something that Wolfram has sent out, or maybe someone else has sent out. But these would be forms that you can easily deploy and create that have some kind of input, and it's asking you for information. Maybe you upload a file, you type in a survey, things like that would be these form interfaces. And then the last one, and kind of the one that I'm the biggest fan of, and the one that I use all the time, and the one that we'll talk about here is instant APIs. So you can take your code, your deployed algorithm, whatever it is, and you can put that into the Wolfram Cloud as an instant API. And that API can basically be called from just about anywhere, any kind of platform, right? As long as you have an internet connection, and you kind of have set up the means of calling that, you can call that API. So why though is the Wolfram Cloud so powerful? It really comes down to the way it was designed is much like the way the Wolfram language is designed, right? So everything is a symbolic object. Creating, deploying, and manipulating expressions in the Wolfram language is easy, and as it turns out, it's just as easy to do that in the cloud as it is on the desktop, right? So a really simple example comes straight from the documentation, but if you've got this simple expression here that's just going to give you a dynamic manipulate function, right? You can in one line of code, you can deploy that up to the cloud, and you can kind of give it a special folder and location that you want to put that in, right? And so if that gets deployed, you get returned back this cloud object that has the URL. But what I mean about kind of manipulating things within the cloud is that if you want to delete that same object, that same expression, it's just delete object, and then you call that same cloud object, and it gets deleted, right? If you've ever done something like this in any of the other AWS, Azure, any of the other cloud platforms, right? It's not this simple, right? It's a complicated process to get basically anything up there that you want. And so the fact that you can do these kinds of things in one line of code is truly remarkable. One other thing, I won't run this, right? But moving files back and forth to the cloud is also just as easily, right? If you have some file here on your local computer and you want to just move it into a place in your cloud, right? You can copy the file and give it the new path that you want, and you're kind of on your way, right? So it speaks to just the power and the ease of use of the Wolfram Cloud. All right, so kind of getting into some of the more technical side of this. So how does this actually work? So what I'll talk through here is the Wolfram side of things, so deploying APIs. And I'll start with just a simple example. So if you've ever done this before, right, you can basically take any kind of function you want and turn it into what's called an API function in Mathematica, and that's just a little bit of a kind of overhead function to sit on top of whatever else you've maybe developed, right? That says to the Wolfram language, hey, this is a proper API. I'm going to expect certain inputs, and I want those inputs to be in a certain form, right? So you kind of define that. You can call this within your Wolfram language, no problem, right? You give it an association with your input X and your actual value there, and it just go ahead and runs that function, and it gives you back your result, right? Now, kind of going to the same point of what I was speaking on the last slide, deploying that is just one more line of code, right? So we take this API that we've produced, we give it a location. In this case, I'll make it public so that we can easily kind of call it here, and you're kind of on your way, right? So you deploy that. Now you have this URL, and that can be used to call this function from basically anywhere in the world and through any platform that you want. The Wolfram language itself has some ways of kind of doing that within the language too. So you can use this URL build and give it the association, and then you've got a link now that if you were to paste this into a browser, it would actually run your function, and it would pass to as the input. You can do that more directly with something like URL execute. But these are how you call the APIs, right? Ultimately, you're putting this URL on, and you're passing in whatever variables you want. Just to kind of show the real strength of the Wolfram Cloud, right? That's obviously a pretty simple example I did before. Still kind of keeping it somewhat simple, but if I have, say, something that I'm trying to predict, right, and maybe it's actually it's not a scalar, but it's an array of values, right? I've got two different kind of data sets here that are just basically linear lines, but they've got some noise associated with them. If I wanted to predict that, and say I actually wanted to use a neural net to do that, right? I can train a really simple neural net that's going to basically just do a linear regression type fit on that data. But the output of that neural network when it finishes training is going to be an array, right? So I've got one variable coming into it, and then I'm going to return back two predictions, one for this data and one for this data. And so I can actually, I'll go ahead and stop it there, but I can actually, I can run that model locally, right? So it's running this neural network that I've created. I can run that locally, and just like we did with the simple trivial example above, I can again just take that model exactly as it is, this neural network, and I can deploy that to the cloud. First, I can call it locally in the same way. I'll get back this array, and then I can deploy that entire neural network to the cloud. So now I have a API that's been deployed. I've got a URL that I can call, pass in whatever arguments I want, and I'll actually get back a result from running my neural network, right? Again, just if you've ever done this in any other cloud environment, right? It's not this quick, right? You may know that. So So this kind of speaks to the Wolfram side of things. So how do you call these APIs though from Excel in this case, right? So at our company we generally have a pretty strict no VBA policy, right? And the reason is just, VBA is fine when you have no other tools, right? But there's so many better tools than VBA. So if you're writing for loops and things like that in VBA, I always encourage people, hey, do this in Wolfram language, do this in Python, do this in anything kind of but VBA. But in this case, right, because we're calling an API from Excel, we do need to actually use a little bit of VBA. And there's some other ways that you can navigate this that don't require VBA, but I think it's still the simplest. So going back to our kind of simple API previously, right? Here's a little screenshot of the code that you would use to call that API within VBA. So you create a new function. In this case, I'm just going to call it x+2. I'm going to have this URL, which is that exact same URL I showed in the previous slide, and then I'm going to pass in my argument of x, which is coming into the function as in Excel as an argument. I'm going to create this object, this is kind of the secret to be able to actually call in a URL from VBA is this code block right here. You create this MS XML object. You're going to do a get on it. You're going to set this request header, send it, and then you're going to get returned back this response text. Once you've done all that, then it's just a matter of setting this your function output equal to the result that you get, and you're kind of on your way. If we look at the more complicated example, it's still not that bad. It's just a little bit more, because in this case we are returning an array, right? And I didn't mention this on the previous slide, but when I deployed my API, I told it specifically, hey, when you return this back to me, I want you to return it as a JSON object. And so when it does that, you can see that the result that I get from just calling that URL through the VBA code is going to give me back this number bracket, right? And this is really a JSON, and it's a familiar language to move numbers and arrays and values around on the web side of things. So I'm going to get back this JSON in string form, and so to parse it, I just have to add a couple more lines of code here that's going to say take these two brackets, kind of get rid of them, and then split that string by a comma, and now all of a sudden I've got two values, and then I can actually tell Excel to output those two values into two different rows or two different cells, and so I get back an actual array in my output. So putting this all together, right? This simple example, you end up with, you put that code into your VBA, and you end up with this function here that you can call, right? It's x+2. It's a real function. You can have all these imaginary inputs here, and you can have this x+2 function that you're just inputting here and basically dragging down in the normal Excel manner. If you look at the slightly more complicated one here, we're calling a machine learning model. It's outputting two values, right? So we're going to get an array of values every time we call it, and you can set something like that up in this way, or you could also do it vertically if you'd like to do that. So this is kind of what this process looks like in a very simple manner. I thought maybe I'd end the talk by just walking through a slightly more complex example. So what we've kind of really focused on is kind of why you'd like to combine the Wolfram Cloud and Excel, and then how you actually do that. But to give a better example of how we use it, I would just give you a little bit of background about kind of this use case. So at our company, we deal with a number of industries, but by far the largest is energy, and in particular, one of our areas of expertise is in something called flow assurance. Just like its name implies, the goal is to assure that you have safe and efficient flow of your hydrocarbons from reservoir to any kind of receiving facility, and that's often much easier said than done, especially when you're dealing with harsh conditions offshore, which is where we tend to operate most of the time. So in an offshore environment, you can be producing at water depths of over a mile below the sea, where ambient temperatures are just a few degrees above freezing. So all kinds of things can kind of go wrong in those environments. Things get very, very problematic, and a lot of things you have to worry about. This is a picture of something called hydrates, which are ice-like structures that form in your pipeline when you have water and gas present, and how you prevent and mitigate hydrate formation requires a combination of some complex physics-based models, as well as the ability to perform, solver-type functionality on the fly as you determine the correct chemical dosing to inhibit these things, and all kinds of things like that. So naturally, these are kind of the exact type of calculations that you don't really want to be trying to code into something like VBA, right? If you can avoid it. But Excel is exactly where a lot of engineers, and in particular oil and gas engineers, they still live, right? You always got a spreadsheet in front of you. You're looking at field data. You're trying to do some quick calcs and things like that. So Excel is readily available. It's where you want these things to be deployed. So here's just a little screenshot of a utility we built for an offshore operator that allows them to do all kinds of things, ranging from predicting hydrate formation conditions to determining the correct amount of chemical inhibition, like I mentioned before. And this tool, in total, I think it has around 10 APIs that it's leveraging, all of which are deployed on the Wolfram Cloud. And some of those are returning, scalar type calculations, like I showed, while others are actually outputting entire arrays of data and curves. Some of these curves that are in the plots and things like that, these are pressures and temperatures that it's outputting, 20 different values at once. And so at the end of the day, this is still Excel, right? Which means it's not going to be as pretty as you might hope for, right? I mean, the user interface, that is, but the fact that this can exist in a platform that everyone has, it can be emailed around, and it can do all that while still leveraging some rather impressive algorithms behind the scenes, ultimately makes this for a very, very useful tool, right? So with that, I'll wrap up. Just to kind of conclude, I think Excel is still an important tool used throughout industries, and therefore it shouldn't be dismissed in terms of providing solutions in it. I think the challenge, of course, is delivering what's possible with today's modern technology through something like Excel, right? And this, to me, is where the Wolfram Cloud can come in, right? Which is such an amazing platform for easily deploying very complex technologies in just a few steps, really. So combining these two, to me, I think is a really neat idea. It really provides kind of the best of both worlds when the situation calls for it. So with that, I will close, and let me see if there are any questions. Thanks for going download your. So yeah, I forgot to post the notebook. I will go back and see if there's a way I could post a notebook so this can be downloaded. Another question: for a tool that would be used by a single user, is it possible for Excel to call an API that executes on a local copy of Mathematica rather than the Wolfram Cloud? Yes, this is possible. So if there's any talks out there, I'm not sure if there are this year or not, but there's something called the Wolfram Engine. So it's basically the core engine behind the Wolfram language, right? Those can be downloaded and installed, and there are ways that you can actually call directly into a local copy of the Wolfram language directly kind of on your desktop, right? So you need languages, you need a more of a programming language approach at that point. It'd be less API based, like web API type based, but you'd be calling into the Wolfram engine from, say, something like C# or a more C++, more traditional programming language that's going to let you do that on the desktop side of things. We've done that on occasion as well, to actually try to deploy very complex production applications that are required to be local, not necessarily web based, and they don't have URL access, things like that. So what is the current status regarding Excel connectivity via cloud connector for Excel? Yeah, will the add-in be developed further? Do you have any knowledge about this? I've looked at the cloud connector for Excel a little while back. What I found there, right, is that it was and I could be misspeaking on this, maybe it's been updating, but what we saw was that you couldn't have things kind of remain readily available for you, right? It was hey, go do this calculation, come back, and the next time I come back to the cloud connector, it's a brand new instance, right? So if you want to deploy something that you've created, you need it to be able to stay there in in perpetuity until you do take it down. So that's where you need a proper API to be deployed that's has your exact code and things like that. Again, I could be wrong about that. Maybe there's been a change on some of that. It's worth looking into. Yes, and there's also mathematical link for Excel. Yeah, again, I think there's a price associated with the mathematical link for Excel. There's a little bit of that's a great product as well. I think if you're looking to deploy this across an entire organization, potentially the cost is going to get prohibitive. You've also got to worry about people actually installing all of that, things like that, right? The nice thing about what I've presented here is you hand people just an Excel sheet, right? It's very, very little overhead. It's just, here is your Excel sheet, and all the math, everything that's going to be called behind the scenes is sitting up in the cloud, right? So it's not taking up the file space or anything like that. It's very, very streamlined way to hand out technology and hand out an application. All right, I think that is it. So we can go ahead and close if there are no other questions. Thank you all for attending.